Hello students. So today we are starting with the new topic called application of integrals. Okay. So we have learnt integrals, definite integrals, in which we used to take limits, right? So integral is nothing but we are trying to find out the area under the curve. Okay. If there is one curve like this, then area under this curve is given by the integral. That is, we are taking a small part. Okay, we are finding that from some limit. Okay, so we have to start from this point to this point. Okay, and then we have to add this. That is what gives us integral. Okay. So let's start with this area under simple curves. Okay, so if the curve is like this, okay, this point is x equal to a and this is x equal to b. Okay, then the area of this figure a, b, c, d. Okay, we have to consider first a small strip. Now this distance, this is your x-axis and this is your y-axis, right? So this distance is your y, the strip is y. Okay, and we are moving from x equal to a to x equal to b. So this becomes our limit. Okay, and this we take as function of x. Y we write it as a function of x. So we are considering small strips, okay, of y, and then we are adding them up. So it becomes an integral. So area of this curve is given by integral a to b, that is limit, okay, y dx, and y is nothing but f of x. Okay, now suppose the curve is, you have to draw it again. Curve is on the y-axis like this. Okay, then this point is your y equal to some a and this is your y equal to b. Okay, now we have to consider a strip x. Okay, small strip x, and this function you can take it as some function of y. So we are moving from a to b. Okay, we are considering small strips and then we are adding them up. So area of this curve will be integral a to b x dy. Okay, we are changing y now, that's why it is dy. So x is g of y dy, function of y. Okay, so these are area under simple curves. Let's see some examples. So here we calculate three types. That is, first is to calculate area of the circle. Okay, so equation of the circle is what? Equations I am going to write. Okay, so equation of the circle is x square plus y square equal to r square. Okay, so for a circle we consider this strip or the horizontal one. Okay, one of them you have to consider, and you are considering this part, that is quarter, right? So to get a full circle you have to multiply by 4. Later on, after finding out this part, you have to multiply that by 4. Okay, then we need equation of an ellipse. Now these are the equations which you have learned in your 11th standard. This is an ellipse. Okay, this distance is a and this distance is b. Okay, this is horizontal one. So ellipse equation is given by x square upon a square plus y square upon b square equal to 1. Okay, if the ellipse is vertical like this, there are two types of ellipses, then this part is your a and b are same. Okay, just you have to see, you have to draw and see, okay, which one is a and which one is b. Then we have parabola. Parabola are of 4 types. Okay, first one is upward, then we have downward. Okay, this is, so we have upward parabola like this. Okay, and the equation is given by y square equal to 4ax. Okay, if it is downwards, then the equation is given by should be, no, this is x square. Okay, because it is upwards, right? So x square equal to 4ay. If it is downwards, then it becomes negative, x square equal to minus 4ay. Okay, if the parabola is right, okay, then this becomes y square equal to 4ax. If it is left, then y square equal to minus 4ax. Okay, so you have to see accordingly which parabola it is. And ellipse, the second type of ellipse is x square upon b square plus y square upon a square equal to 1. Okay, so here the x part is b, that is the smaller one, like this you will have, or vertical one. Okay, so this is circle, ellipse, parabola. About parabola have a latus rectum. Okay, so here this line, okay, which passes through the focus, this line is called latus rectum. Okay, this you remember. Okay, now let's solve some problems. Find the area enclosed by the circle x square plus y square equal to a square. Okay, first you draw the figure. So this is your circle. Okay, now it's up to you which strip you want to consider, y or x. Okay, so first I am going to consider the y strip. This is y strip. Okay, so you have to move your x points. So x is from, now here the radius is a, right? So your this distance will be a. Okay, so this point will be a comma 0, right? Now this distance is also a because it is a radius. Okay, but this point will be, it is on the y-axis, so this point is your 0 comma a. Okay, and this is your origin 0 comma 0. So the points are changing from 0 to a, x points are changing from 0 to a, and this is your y. So y in terms of x you have to write, so you have to convert this. So y square is a square minus x square. So your y is root of a square minus x square. Now you have to consider the limit 0 to a y dx. Okay, with respect to x we are changing the limits. So 0 to a, in place of y you have to write a square minus x square dx. Now make use of the standard results which we have studied in integration. So this is your x by 2 root of a square minus x square plus a square by 2 root of, no, this is sine inverse, right? Sine inverse x by a. Okay, now you have to put limits from 0 to a. Okay, now you have to solve this. So you have to put 0 and a. First you have to put a. So let's rub this. So I'm putting first a in place of x, a by 2 root of a square minus a square plus a square by 2 sine inverse a by a minus, now the whole thing, this thing with 0. So first term will be 0 because 0 into this, and then it is sine inverse of 0 by a. So that term is also 0. Okay, so this term is also 0. So only term remains is this, a square by 2 sine inverse of 1. What is sine of 1? Which this has sine of 1, it is 90, yeah, sine 90. So this will be sine inverse of 1. In place of that you can write pi by 2. So the final answer is pi a square by 4. Okay, now this area is of only the quarter part, right? We need area of the whole circle. So you have to multiply this area by 4. So your final area is 4 into pi a square by 4. So final area is pi a square. Okay. So the questions, this is in general, it is given, a general circle is given. So the questions can come in specific form, that is they may give you radius, that is sometimes it is written 25, so the radius is 5. So in place of a you have to substitute 5. Okay, and the whole process is same. Okay, before moving on to second question, you can also consider the x strip. Okay, so your equation will be a square minus y square, so x is root of a square minus y square, and this point changes, y points are changing. So this is 0 comma 0 and this is your 0 comma a, right? So 0 to a you are changing, same limits will be same. Okay, only the question will be in this form. Now in this you have to find the area enclosed by an ellipse. Okay, this part we are considering. Okay, so whichever you can take any strip, x or y. Okay, let's take x strip. Okay, so if you are considering x strip, this is y, sorry, this strip we are considering x. Okay, so you have to see the y limits. Okay, this point is 0 comma 0, this point is 0 a comma 0, and this is 0 comma b. Okay, so the y limits are 0 and b. Okay, so this becomes 0 to b x dx dy. Okay, we are changing with respect to y. So you need x from this. So from this, what is x? I will write here. X square upon a square is 1 minus y square upon b square. Okay, so this will be b square minus y square upon b square, and this, okay, I will write here, x square is b square minus y square upon b square into a square. Okay, so this root, this will be a by b root of b square minus y square. Okay, so this is your x part. So I will write here only. So now you have to substitute in the integral part. That is, we are changing limit from 0 to b x dy. In place of x, you have to write a upon b root of b square minus y square dy. Okay, now a by b is your constant. You can take that outside. So this thing remains. So you have to apply the standard formula, standard result for this. That is same as the previous one. Okay, let's write it down. X, so in place of x it will be y by 2 root of b square minus y square plus a by 2, a square by 2, that is b square by 2, sine inverse x, that is y by b, right? It is from 0 to b. Okay, so now you have to substitute the limits. So in previous one we have got only this limit, and here also we will get only this limit. Okay, because the 0 part is 0 and b part, when you substitute here, it becomes 0. Only thing remains is this part. Okay, I will write here sine inverse a by b square by 2 sine inverse of 1, it remains. Okay, and this is pi by 2, so we'll get a by b into b square by 2 pi by 2. Okay, one of the b gets cancelled, so it is pi ab by 4. This area is of only this part, right? So we need such 4 parts, so you have to multiply by 4. So the final answer is pi ab. Okay.